Elon Musk's recent introduction of the revolutionary anti-gravity fighter jet came at an extremely crucial period as nations across the world race to enhance their defense capabilities and secure technological superiority. This groundbreaking aircraft, which offers a significant strategic advantage, has shocked the world. What impact would this aircraft have in the aviation world? What are the capabilities of this mind-blowing innovation? Join us as we unveil the anti-gravity aircraft that Elon Musk recently introduced. Quite recently, SpaceX's Starship rocket made big progress during its third test flight, achieving many of its goals. The two-part rocket successfully launched from Texas and aimed to send its top section around the world for a re-entry over the Indian Ocean. Although radio contact was lost near the end, the company said it was amazing to see how far they made it this time. SpaceX CEO Elon Musk was also very happy with how the flight turned out. Last year, when SpaceX's 120-meter-tall rocket launched in April and November, it exploded shortly after liftoff. This time, Elon Musk was hoping for a much better result from his SpaceX team, and he got exactly that. The rocket roared to life with a massive blast from its 33 engines, smoothly executing every stage of its climb into space right on schedule. The lower half, called the booster, separated from the top half, known as the ship, 2 minutes and 44 seconds into the flight. The ship continued its journey, soaring over the Atlantic and southern Africa. Along the way, video cameras captured breathtaking images of Earth from over 100 miles above. Next was the challenge of re-entry, where the ship had to come down for a splashdown in the ocean. Video footage showed amazing scenes as hot gases surrounded the vehicle right before radio contact was cut off. Soon after, controllers reported that the ship had been lost, likely because it had broken apart. Not everything went as planned. After separating from the ship, the booster was supposed to slow down and make a controlled landing in the sea near the Texas coast. It got close but seemed to come in too fast and was lost before reaching the water. The ship was also supposed to restart its engine for re-entry, but that didn't happen for reasons that aren't clear yet. These issues can be looked at again once all the data is reviewed. Overall, though, engineers are confident that progress on the world's most powerful rocket is on track. Elon Musk has even promised up to 6 more test flights this year. Starship is unlike any rocket we've seen before. The 33 engines on its booster generate 74 meganewtons of thrust, far more powerful than any previous rockets, even the ones that sent astronauts to the moon in the 1960s and 70s. If engineers can perfect it, Starship will be a game-changer. The rocket is designed to be fully reusable and quickly ready for another launch, similar to how airplanes are refueled and put back in the air. This ability, combined with its capacity to carry over 100 tons into orbit in one trip, would drastically reduce the cost of space missions. For Elon Musk, Starship is crucial for his Starlink project, which is creating a global network of broadband internet satellites. There are already over 5,000 Starlink satellites in orbit, and the new rocket will be able to launch even more. During this test flight, they successfully tested the opening and closing of a door that will allow future Starlink satellites to be released. Starship will also help Musk achieve his longtime dream of sending people and supplies to Mars to establish a human colony. The U.S. space agency NASA was one of the most interested observers on Thursday. Starship is a key part of NASA's Artemis program, which aims to send astronauts back to the moon this decade. A special version of Starship would be used as a landing craft, taking the crew from lunar orbit to the moon's surface and then back up again. Before astronauts can board, SpaceX will need to prove that Starship is safe and reliable. NASA hopes to see this happen by late 2026. The Federal Aviation Administration, FAA, which oversees commercial spaceflight in the U.S., announced that it would investigate the mission due to how the booster and ship ended their flights. This is a routine step, and SpaceX will lead the investigation to review what went well and what needs improvement. This, too, is standard practice. SpaceX's first rocket, the Falcon 9, was a significant achievement as it became the first privately funded liquid-fueled rocket to reach orbit. The Falcon 9 rocket was designed to keep launch costs low for satellites in low Earth orbit, improve reliability, and streamline the launch process. It also served to test parts and design concepts for the larger Falcon 9 rocket. SpaceX focused on creating a smaller, simpler rocket that could carry around 450 kilograms to orbit, aiming to avoid financial issues that could arise from building something larger and more complicated. The first stage of Falcon 1 was made from a strong aluminum alloy and used a single Merlin engine. It featured a parachute system for safe recovery. The engine underwent improvements with the Merlin 1C version used in later Falcon 1 flights. This stage provided 92,000 pounds of thrust and burned for about 169 seconds. The second stage was constructed from a material suitable for extremely cold conditions and was powered by a Kestrel engine. It had a pressurization system to control propellant flow in thrusters. The Kestrel engine generated 7,000 pounds of thrust in space and was designed to be efficient. SpaceX initially offered the Falcon 1 rocket at a fixed price of $5.9 million in 2005, which later increased to $6.7 million by 2006. In 2009, the price was updated to $7 million for the Falcon 1 and $8.5 million for the improved Falcon 1, with discounts for multiple launches. By 2012, SpaceX shifted payloads originally meant for Falcon 1 and wanted to fly as secondary payloads on the Falcon 9. The Falcon 1 was originally intended to carry 600 kilograms to low Earth orbit for $6 million, but later was limited to 420 kilograms as costs rose to $9 million. The final Falcon 1 model was designed to carry 1,000 kilograms for $1 million. Even though it was retired in 2009 after 5 launches, its success laid the foundation for SpaceX's future missions. The Falcon 9 medium-lift rocket has become crucial for SpaceX. It has 2 stages and is capable of carrying medium-sized loads into space. The first Falcon 9 launch happened on June 4, 2010, and its first mission to resupply the International Space Station was on October 8, 2012. In 2020, it became the first commercial rocket to send humans into orbit. By 2021, it had the most launches of any rocket in history. The Falcon 9 has a strong safety record with 364 successful launches, 2 in-flight failures, 1 partial failure, and 1 pre-flight destruction. The Falcon 9 rocket has 2 stages. The first stage, known as the booster, carries the second stage and the payload to a certain speed and height before the second stage takes over to deliver the payload into orbit. What makes the Falcon 9 special is that the booster can land vertically for reuse, a remarkable achievement first pulled off in December 2015. As of August 28, 2024, SpaceX has successfully landed Falcon 9 boosters 326 times, with some boosters flying up to 23 missions. Both rocket stages are powered by SpaceX's Merlin engines, which use supercold liquid oxygen and rocket-grade kerosene fuel. Falcon 9 has carried some heavy payloads into space, including the Intelsat 35E and Inmarsat 19B. It even set a record on January 24, 2021, by launching 143 satellites in a single mission. Falcon 9 is approved to carry NASA astronauts to the International Space Station and is certified for critical national security and high-priority NASA missions. Multiple versions of Falcon 9 have been built, with the latest, the Block 5 variant, in operation since May 2018. Both stages of the Falcon 9 rocket use Merlin 1D engines. Each Merlin engine produces 192,000 pounds of thrust. These engines are ignited using a special chemical mixture called TETB. The booster stage has 9 engines arranged in a pattern SpaceX calls Octaweb. The second stage has a single Merlin 1D engine with a shorter or regular nozzle, depending on the mission. Falcon 9 can still complete its mission even if up to 2 engines fail, by running the remaining engines longer. Each Merlin engine is managed by 3 computers, each with 2 processors that constantly check one another. These engines can also adjust their thrust direction to control the rocket's flight path. The walls and domes of the Falcon 9's fuel tanks are made from an aluminum lithium alloy. SpaceX uses friction stir welding to make the tanks, which provides extra strength and reliability. The second stage tank is a shorter version of the first stage tank, using the same materials, tools, and manufacturing methods. The interstage, which connects the rocket's upper and lower stages, is made of a carbon fiber and aluminum core composite. It includes reusable separation systems and a pneumatic system that pushes the stages apart. The original design had 12 attachment points for separation, but this was reduced to 3 in the version 1.1 Falcon 9. Falcon 9 rockets use a nose cone called a payload fairing to protect the spacecraft during launch and ascent. Satellites during launch are protected by a fairing. This fairing is 13 m long, 5.2 m wide, weighs about 1,900 kilograms, and is made of carbon fiber over an aluminum honeycomb core. SpaceX designs and manufactures these fairings in Hawthorne. They were tested at NASA's Plumbrook Station in 2003, where launch conditions such as loud noises and vibrations in a vacuum were simulated. Since 2019, these fairings have been designed to return to Earth and be reused for future launches. For the control system, SpaceX uses multiple backup flight computers with a fault-tolerant design. The software runs on Linux and is written in C++. Instead of using specialized parts, they rely on standard components with a radiation-resistant design. Each rocket stage has its own flight computers, and each engine has its own controller, all using a reliable system to manage stage control. The engine controllers run on PowerPC processors. Boosters that are not meant to be recovered do not have landing legs or fins. However, recoverable boosters have 4 extendable landing legs at the bottom to guide the core as it falls through the atmosphere. SpaceX also uses grid fins that pop out from the rocket after the stage separates. The original Falcon 9 version 1.2 full thrust had aluminum grid fins, but these were later replaced with larger and more efficient titanium fins. The titanium fins are better at handling the extreme heat of re-entry and can be reused multiple times with only minor maintenance. Aside from the Falcon rockets, Elon Musk has developed something extraordinary. Amid all the chaos, Musk's boldness has led to the creation of a real UFO-like craft called the X-1, which is closely monitored by the U.S. government. This impressive vehicle, developed through years of work at SpaceX, can reach hypersonic speeds of 4,600 miles per hour and is very fuel efficient. Musk's move into advanced aerospace technology raises important questions about how innovation intersects with global politics and conflicts. What makes the X-1 special is its unique camouflage technology, making it almost invisible by blending into the sky like a cloud. The Pentagon was initially confused, mistaking it for a UFO and sending fighter jets after it, adding a layer of suspense to the story. Musk's secrecy around the X-1 even caused confusion among Hamas militants. The X-1 is also remarkable because it is the only aircraft equipped with a compact space shuttle engine, previously seen on SpaceX's Hawk hypersonic missile, which can travel over 4,600 miles per hour and bypass modern missile defense systems. This engine now powers the X-1, which also features a design that cuts fuel consumption by 30%. The spacecraft is also equipped with microwave technology, which can melt enemy aircraft or disrupt their electronics, potentially changing modern warfare. There is also an unusual use for the system. If the radiation is turned down and aimed at a person, it causes intense pain, making them flee and abandon their equipment, which could then be captured. The X-1 could be a major asset for the U.S. military, but Musk and the Pentagon disagree on how to use the technology. This tension adds to the intrigue. While Musk sees it as a potential strategic weapon, the military is more cautious, leading to a debate about the role of such advanced technology in modern conflicts. Despite the disagreement, the X-1 continues to amaze. Its stealth technology avoids radar detection, and it can fly at an incredible altitude of 105,000 feet, even higher than the famous State Route 71 Blackbird. This combination of speed, invisibility, and altitude could transform space travel and air defense. However, like all aircraft, the X-1 is not invulnerable. Supersonic missiles would be needed to challenge it. This is where the advanced technology of the F-35 Lightning II and F-22 Raptor comes in. Thanks for watching. While you are still here, click on the link appearing on your screen to check out another of our videos. See you there.